Okay, part A, here's my vectors P and Q. I want the angle between P and Q. So once I angle with vectors, it's a scalar product. Put down the definition. P dot Q is mod P mod Q cos theta. So let's evaluate the left hand side. So P dot Q is 2i minus j plus 3k dot 5i plus 4j minus 8k. So the i's, I dot I is 1, j dot j is 1, k dot k is 1, everything else is 0, so that's 2 times 5 is 10, minus 1 times 4 is minus 4, and 3 times minus 8 is minus 24. So that's 6 taken 24, that's minus 18. Work out the modulus of P. It's the modulus of 2i minus j plus 3k. So that's the square root of, right, coefficient of I squared, so that's 2 squared, plus coefficient of j squared is minus 1 squared, plus coefficient of k squared is 3 squared. That's 4, plus 1, plus 9, so that's the square root of 14. Mod Q is the modulus of 5i plus 4j minus 8k. That's the square root of coefficient of I, so that's 5 squared plus 4 squared plus minus 8 squared. That's the square root of 25 plus 16 plus 64, which is the square root of 70, square root of 105. So substitute these values into my definition there. So that's minus 18 is equal to square root of 14 times the square root of 105 cos theta. So cos theta is minus 18 over root 14 root 105. Let me find theta, we type it in. Make sure you're in degree mode. Shift setup 3, and then type in what I got. So that's shift cos minus 18 on top, and square root of 14 square root of 105 equals, and I got 118.000 and so on. So that's 118 degrees to the nearest degree. Okay, so that's part A. Alright, part B. Okay, so I've got a diagram here. In the exam I'd have to redraw that diagram on my sheet, but as soon as it's drawn I'll use it. O, A, B, C and D are points such that A is the midpoint of OD, so that's the midpoint of OD, and C is the midpoint of OB. Taking O as the origin, the position vector of A and B are A bar and B bar. So what I know then is that O to A is A bar and O to B is B bar. Well, in part 1 asks me to find the vector C to D. Now then, to go from C to D, I go from C to O, followed by O to D. Okay, so O, because C is halfway between OB, then vector O to C is half of vector O to B. O to C is half of vector O to B, and O to B was B bar, so that's half of B bar. O to D, because A is in the middle of O to D, then O to D is double what O to A is. So it's 2 lots of O to A, which is to A bar. So C to D, C to O, so that's minus a half B, plus O to D, which is 2A. And they've written it the other way around. Okay, hence show that the vector equation of the line CD can be expressed in that form. So the vector equation of the line CD is R bar equals, now then, vector equation of the line CD, I've got to get onto the line, so that's O to C, plus lambda times CD. So R bar equals, now vector O to C is half of B, plus lambda times CD, which is 2A minus a half of B. So let's expand that out, because I got letters to collect like terms, plus 2 lambda A minus a half lambda B. So R bar equals, that's 2 lambda A plus half, and it's 1 minus lambda B bar. Right, it tells me the vector equation of L can be expressed in that form. It tells me that the lines CD and L intersect at E. Show that E has that position vector. So here's the vector equation of CD and L, so they're going to intersect. Okay, part 2, they intersect when this line, 2 lambda A bar plus a half of 1 minus lambda B bar is equal to this line here, 1/3 mu A bar plus 1/3 of mu minus 1 B bar. So I compare coefficients of A and B. So 2 lambda on the left equals 1/3 of mu, and for B a half of 1 minus lambda equals 1/3 of mu minus 1. Okay, so I need to solve these simultaneously. Let's multiply out the second one. So it's a half minus lambda over 2 is mu over 3 minus 1/3. Okay, now I can see by multiplying out now that mu over 3 I can replace with 2 lambda. So sub for mu over 3 equal to 2 lambda in 2. So half minus lambda over 2 equals 2 lambda minus 1/3. Flip the lambda, so that's 2 lambda plus lambda over 2 on the right hand side, and it's half plus 1/3 on the left. Half plus 1/3 is 5/6. 2 lambda plus lambda over 2, so that's 4 halves and 1 half, so that's 5 over 2 lambda. So multiply up by 2, so that's 5/6 times 2/5 is lambda. 5's cancel out, that tells me lambda with a value of 1/3. Now sub into 1, so if lambda is 1/3, 1 tells me that 2 lambdas, that's 2/3 is 1/3 of mu. So mu is 2/3 times 3, so mu is equal to 2. Okay, so I want the position vector of the point of intersection. So I either substitute the mu equal to 2 into the mu equation, or the lambda is a third. So the easier one to substitute is the mu equals 2. So the point of intersection, right, the position vector, or the point of intersection, so I'm talking about OE. I put mu equal to 2 into this equation, so that's a third of 2, so that's 2/3 of A plus 1/3 of 2 minus 1 B. So that equals 2/3 of A plus 1/3 of B, which is what was asked in the question. It says, give a geometrical interpretation of the fact that E has a position vector of 2/3 of A plus 1/3 of B. Okay, so just looking at what we got set up. Haven't worked anything out with it's in the same ratio. I'm looking for something in the same ratio here of 2A plus a third of B. I haven't got that. So 2A plus 1/3 of B. So CD was intersecting with a line. It's going 2/3 of A, so motor A is there, so it's going 2/3 along there, and a third of B. Moment I think 2A plus B would be to there. That's 2A bar plus B bar, 2A plus B, so that would be a parallelogram. Just there, so 2/3 A plus B. Yeah, I've seen it.